Hello, it's Keith here, and this is the 6th episode of the Z80 programming project. So what's been going on? Well, here's the latest version of the game. You can see most of them are paused here, but I've got two of them running here. And you can see on the game gear, we've now got some animation going. So you can see each of the tile sprites has got 2 frames. And on this screen here, it's just sort of ticking away just to keep some movement going. And if I unpause some of these other systems, you'll see the animation does work on all of them except for the TIE-83. And the reason for that is the screen's so small that you can't really see things clearly at the best of times, so it didn't seem appropriate to have animation on that. And as always, it's basically using the same sprites on all of these systems, so it does tend to look the same on all of them. Now, the TIE-83 has got the final versions of the sprites now. I did a proper refresh and made them look nice. Because the TIE-83 screen's so small, they're very basic, but I think they look pretty good now. On the other systems, the 2-colour and 4-colour systems, the sprites still need some work, so that's this one and this one. But the 16-colour systems, I'm not planning on doing any more work on them. But, I mean, anything can change. I've still got one more day to go. So let's close these down so that the computer doesn't start heating the room up too much. Not that's too much of a problem today because we've actually got sort of flooding and things going on in the area. I had a quite nice wake-up call from the emergency system, which automatically phones everyone in the morning. There was about 6 calls at 6 a.m. saying, oh, evacuations and get ready to evacuate and things. So the joys of Japan in the rainy season, that is. So let's have a look at this then. So you can see now we do have some slightly nicer sprites. They're very simple, but they have to be because they are 4-pixel square sprites. But I think they do the job quite nicely now. No animation on the TIE because, as I say, because of the screen blurriness and speed and because of the tiny pixel size, it didn't seem appropriate to keep the animation. So whereas the other systems are swapping between 2 different sprites, the TIE-83 is just using a single sprite. So let's have a look at the game gear, which is more representative of the... It's running a bit faster, it seems. I do still on my... It's on my to-do list to work on the control, the speed on all the systems to make them match. Before there was a delay, and I've now taken that delay out because I'm assuming the animation is going to slow the systems down enough. But on a system with very good hardware acceleration like the Game Gear and a very small screen size, that's probably not true. Well, it certainly seems this is rather too fast, so either I need to do more animating or bring that delay back in. But as you can see, the game is it's got some animation now. It still plays nicely. I did have to make some changes. If I just bring the TIE version back up a moment. I have had to make some design changes on the TIE version, which is why I've only got 1 life at the moment because I was having to do a lot of testing on the game over screen. You'll notice on the other systems the high score shows on the front page, but there's not really room for it on here. So the high score on this version actually shows on the game over screen. Quite disappointing with no sound, but to my knowledge the TIE-83 doesn't have any sound capabilities at all, not even a little beep. So you can see here's the sort of game over effect. And then after we've died, it shows the score, the high score. It shows that we're dead, and if we got a new high score, it shows it. So that's the sort of trade-off. But as I say, I mean, it's a more limited system. But to be honest, the TIE-83 version, it was a bit of fun just to see if I could really make this game work on that system, because I do have a certain respect for the TIE-83 because of its longevity being still released and things. But as I say, it's very basic compared to the other systems we're working on. Now, I have intentionally left a bug in the... well, it's not a bug as such. I've left a limitation in the CPC version, and that is I've only programmed in 1 tile bank because there should be 2 now. The first 16 sprites should be the first frame of animation, and the second 16 should be the second frame, but the second 16 are missing from the CPC. And this will allow you'll be able to see some corruption appear on the screen, but this will show you the pattern that the screen's updating. Now you can see there's this kind of waving in effect, and what I'm doing is I'm skipping every 6 tiles, I think it is, and that's so that you get this kind of checkerboard effect, so it looks nice and smooth, because before it was it was updating the tiles in vertical lines, which gave it a very, it wasn't too bad, but it gave it a very unusual looking feel. So this is a bit more random, but still mathematically linear. So let's have a look at the code. Now I'm going over the code again, doing a lot more documentation, and it should all be documented by the end of tomorrow. So hopefully for the last video I do, we'll be able to see all of the documentation in place. And as I've said before, I'm planning to do a final summary episode in which I go over the final code and just describe it all again, because bits of it are changing and bits of it may change tomorrow, because as I said, that's still that speed problem. Oh, one interesting thing, I said there was a pause bug on the master system. I don't think there is. The button that I'd got mapped to pause, I think, is actually the reset button on the master system, so that's probably why pressing that button was resetting the machine. But anyway, so here is the code that forces the animation. All it does is it's messing with the backup tile map again, because any changes to the backup tile map will force a refresh of the tile map that's being shown on the screen, because it only updates tiles on the screen that have actually changed, you see. So what we're doing is we've got this here, which is the size of the tile map. We're dividing by 6 because we're moving in 6s, and DE is set to 6 here as well. I was tweaking this, trying 4 and 8 and things, but 6 seems to be the best. Now we have a second variable. We have animation tick, which is the stage in the animation. So we do it 6 times, and that goes from 0 to 5. And then we've got animation frame, which is actually either 0 or 16, and this is added to the tile that's being shown, and that's how we get the effect of flipping between 2 sprites. Now if we were going to be adventurous, we could have 3 or even 4 sprites, of course. The main reason I'm not doing that is I don't think it would look much better, and the more frames you have, then the slower the movement will become, and it may not look as good. So I'm sticking to 2. I think that's adequate for the purposes of this game, but it certainly is an option. There's no real limitation there because we've got plenty of memory left. So we here's where we're flipping the animation frame once we've updated all the tiles on the screen, but generally speaking we're only updating 1 in 6. So when we get here, we're cycling through the loop. We're requiring A to be 0 here because of this compare command, and what we're doing is we're leaving 0 tiles the same, but any tile that's not 0 we're updating to 255. 255 isn't really used, and so putting 255 into the backup tile map will force the proper tile map to be drawn back to the screen, even if really the tile hasn't changed. And that's because the tile drawing routine has actually is actually now applying that frame. It's adding that frame to it before it does the final draw. So and I did it in this way. I could have changed the tile map, adding 16 and subtracting 16, but I thought that would add more code to other places, because there's a lot of places comparing the tile map to see what kind of object it is, and then I'd have had to do a load of AND commands to remove that potential frame number. So I've decided to do it this way. You could do it a different way. So yep, this is just very simply processing through the entire tile map. As I say, each time only does 1 in 6 tiles. So if I just search for this, you'll see sometimes I'm actually doing multiple. So that will do a third of the tile map. But you know, it's all about the speed of the machine. You know, I actually didn't update more than 2 here, even on the small screens, which could have done more. Because if the entire tile map was updating in one go, it kind of looked a bit too fast and didn't really make it look as dramatic. It started to just look a bit like white noise. So it just depends on the amount of processing power free and the effect you're looking to get. So the force animate here will do the update, and then you need to do the repaint afterwards to actually get the effect. So yep, that's another thing I've done there. That's had some nice improvement. I mean, generally speaking, I've been going over the code and doing some commenting. I found a few little bits that were a bit untidy just because of the general changes to the code. As you can see, I've now got those new those TIE83 graphics that look a lot nicer. The borders are now fixed. I don't know if you remember the Spectrum version and the CPC even. They had the wrong border colours, and also the sound effects were not very good on the Spectrum. They were causing some quite unpleasant slowdowns. So that is now fixed as well. Still struggling with the controls because they're different on all the systems. Well, the systems that have no keyboard, I have to use the cursors, and the systems that do have a keyboard, I can use WSAD, so sometimes I get confused and use the wrong one. But anyway, the sound was causing heavy delays yesterday, and now it's working fine. So that was a change I made there. And I actually have now reprogrammed the palette routines I just made a few tweaks to them. You can now see there's a 17th palette entry here. Because the systems that can support it, the 17th palette entry will now define the border. However, the systems that can't support it will just ignore the 17th entry. So I've made a slight improvement to my palette definition code. And as I've said before, this is going to be covered in my tutorials very soon. This is stuff that I had written before I started the Grime programming project, but all of the work that's not been covered on camera here, that's not been written just for Grime, is all going to be part of my tutorials in the future. So everything you see here and everything that's been used to create this, I'm going to explain fully. And of course, it's all open source, and I really do hope a few people will, take that, download the code, and maybe, feel inspired or take a few code fragments for their own games and things, because what's here, I think, is it's only a basic game, but it's a basic game running on a dozen systems nearly, and that's if you're looking to create something little and simple and get it out there to people with all their different systems, that's got to be a good starting point. So yep, I think generally speaking, yesterday was just a bit of a refinement on a few things, but there's a few things left to do. There's still a big block of code I need to comment. This is looking a bit absent, so I'm going to work on that. But there's a few other things I need to do because it's my last day of programming tomorrow. I say there will be there'll be a summary episode where I go over the source code in detail, describing what everything does, just so everyone's clear. But yep, we need proper sprites. The 4-color systems and the 2-color, the ZX Spectrum, are lacking in their nice sprites, so I'm going to do final versions of the sprites, balancing out the speed. As I've said, some of the systems are very fast, like the Game Gear. Some of the systems, like the MSX2, is very, very slow. I don't know if I can make it better, but it's very slow. Yep, need to try and balance things out. I want to add a new function onto the title screen, which will say press K for Kempson, because as I've said before in my tutorials, trying to read the Kempson joystick on a machine without a Kempson port will cause crazy results. So you'll get the fire button thinking it's pressing and when it's not there. So that's going to be a Spectrum only thing. So I'm going to read the key map directly and read the K key, or maybe the J key, depends what mood I'm in. And finally, we need a proper message for the credits, because it's still saying hello world, and I need to get that nice and sorted. But I mean, generally, the game, as far as playability, I'm hoping it's done. I'm not aware of any serious bugs in it. I mean, there's a few. You could argue some of the tile logic could be improved, but I don't. I'm enjoying playing it, and I think that's all that's really important at this stage. So it's just going to be try and get the graphics looking as nice as possible on all the systems, or maybe a few tweaks to the color palette. Get the documentation finished, and get those few other little changes in. Well, this is the end of the 6th episode. I hope you're enjoying it. I hope you're going to catch the final one to see what the end result is. Thanks for watching, and goodbye.